This is section 2.1, and it is about solutions of linear systems. And what that means is you're going to have two or more linear equations that you are asked to find a solution that solves both of them. Now there's three possibilities that you would encounter here. And as we look here in red, we have unique, which is two lines that intersect at a single point. We have inconsistent, which means two lines are parallel. So you've got two lines doing this. They're never going to intersect and give you a solution. Or you have dependent, which is two graphs that are actually the same line. And so you have one, and overlaying that, you have the same line. So you have an infinite number of solutions that would work. So the next thing that we might mention is the equivalent system. That's one that has the same solutions as another system, as a given system. When we're talking about solving them, you can do any of these steps, and if we look here, number one says we can exchange any two equations. We can multiply both sides of an equation by any non-zero number. We can replace any equation by a non-zero multiple of that equation. In other words, we could say, okay, 3 times that whole equation, and we could substitute it in, and we'll certainly look at examples of that. The Echelon method is a systematic approach for solving systems using the transformations. So there's a couple of examples in the notes here. First one is an example of a unique solution. Remember, that is when we are going to come up with an x and a y that will solve both of these, that will make both of these be true statements. So here we're given two equations, 4x plus y equals 9, 3x minus y equals 5. We want to eliminate the y term, and we're going to start with that because it's pretty obvious here that we have a positive y and a negative y. If we add those two, we could get rid of y. So what's happening in the echelon system or process, if we say row 1 plus row 2 is going to give me a new row 2. So if I add those, you can see if I add, I get 7x. I don't have any y's now, and I have 14. So I have this new row 2. All right. If I divide this whole equation by 7, I'm going to get what x is equal to. So 1/7 of row 2 is going to give me a new row 2, and 1/4 of row 1 will give me a new row 1. So divide the first row, row 1 by 4, row 2 by 7. We end up with what is next. So I have x plus 1/4 y is equal to 9 over 4. And down here I have x equals 2. All right. Then I can substitute 2 for x here. So now I have 2 plus 1/4 y equals 9 over 4. I'm going to multiply through the whole equation by 4. That gives me 8 plus 1y equals 9. If I subtract the 8, you could see that I get y equals 1. And therefore, I have a solution. And remember, it is a point. So this is a point. And the x-coordinate is 2. The y-coordinate is 1. That solves both of those equations. All right, let's look at a dependent one. And let me move this over. All right, dependent, remember, is going to be infinite solutions. All right, so here's our two equations, and I will mark those 1 and 2. All right, if I do 2 of row 1 plus R2, I get a new R2. Why would I want to do that? Over here, if we notice, I have a positive 3 and a negative 6. I could eliminate x if this were a positive 6. Therefore, if I want to multiply by 2, So I do that and I end up with negative 6x minus 4y equals negative 8. And there was a negative there that was by mistake. So when I multiply by 2, this first equation is what I come up with. And when I add those two equations, when I add row 1 plus row 2, I get zeros all the way across, and 0 equals 0. That's a true statement. And so this is important. If you are left with variables eliminated and a true statement, that's what happened here, then this means you have infinite solutions. If you eliminated the variables and you were left with a false statement, that would be no solutions. All right, let's look at one of those. So here's my two equations, and I'm going to multiply row 1 by 2, and I'm going to add row 2 to it to get a new row 2. So 2 times this one will give me 18x minus 10y equals 2, and then I'm going to add the original row 2, and I end up with 0 equals 3. So I've eliminated the variables, but I have a false statement. That gives me no solution. So those are the notes for this section, and this should help you in working the problems for 2.1.